Hello friends and welcome back to your channel. We're going to start with class 9 mathematics. We're going to start a very new chapter here today. That's about chapter 13. It's about surface areas and volumes. Now before we really begin, it's a very interesting chapter also. Okay, if we can relate that to our daily life, no? If we can use our senses. Relate the chapter. So it's very interesting, difficult we know. Practice and then any time let's try to learn today. Before that, like some of the terms that we learned: perimeter, no, surface areas, volumes. So perimeter means length, total length of the boundary. Area means the space occupied, and volume means the capacity. For example, this water bottle is a 1 liter, so the capacity of this water bottle, the volume is like 1 liter. So capacity, that's the volume. So here in this chapter, regarding perimeter, somehow we studied in the previous chapter, chapter 12. So here we're going to study about surface areas and volumes. Now here we are going to generally be studying about three-dimensional figures. We're going to start with cuboid and cube. But before we really jump into cuboid and cube, that's three-dimensional figure, we already know what are these figures, right? Square, a rectangle. So what was the formula? Area mane tai jaga kiman loise itu ki area koi na for. So it will confuse no. Of course, we have a small activity which definitely will help you clarify the concept. So generally, the area of the square was like it's about side into side, because in the square all the sides were supposed to be same. Then of course rectangle, the area was length into breadth. So rectangle is generally where the length are same and the breadth are same. So that's about rectangle. Then we have about square. So generally the rectangle is like a two-dimensional figure, so like a piece of paper. No, this is a piece of paper, so we can consider this as the length, and we can consider this as the breadth. So it will area length or breadth. What is the space occupied, covered, or what is the space taken by this particular paper? So that's going to be the area of this particular rectangular piece of paper. So but now we are going to be studying about two figures, that is like the three-dimensional figure of square and three-dimensional figure of rectangle, I would rather say, which are called cuboid and cube. Cuboid and cube. So generally cube is like something like a three-dimensional figure of a square. Cuboid is like a three-dimensional figure of a rectangle. Not exactly, but in some sense. Okay. So now, for example, if we talk of some examples of cubes and cuboids. So cube, like the magic cube. You know, magic cube, if you recollect, magic cube can be one example. The dice, Ludo, na? The dice can be one example. Cuboids, we have so many examples. Cuboids, like it can be your own textbook, it can be your own notebook, it can be your shoe boxes. So those are cuboids. Cubes, where all the sides are actually same, no, length, breadth, height are all same. Cuboids, length, breadth, height are generally not same. So now for that, of course, I have a big box for all of you. Like for example, if you look at this box, now this is a cuboid. Okay, this is a cuboidal box where I have generally like marked all the figures. Like this is like figure 1. So if we look at the number of surfaces that it has, surface it has, you see, I've actually marked down. You can even take out your textbook also, and then you can just mark, or you can pause the video, go back and just bring a box and then see. So I've marked this surface here, surface 1, piche the surface 2. So if you just count all the surfaces, like this is going to be like, I hope you can see this. This is surface 3, then this is surface 4, this is surface 5, this is surface 6. So in total, how many surfaces do we have in a cube? Cuboid. So we have total faces, I would say, faces in a cuboid. Total faces in a cuboid. How many? We have 6 faces. But the question is, how many choita faces? Not Daila. Believe the cuboid is soft face to ikiase. It's actually no, isn't it? Because when I place the cuboid in this sense, what happens is, see, when I place this cuboid in this sense, I will just let something like this. So what happens is, see, all these faces, for example, like phase 4 is not same as phase 1, because phase 1 is more like a square, whereas phase 4 is more like a rectangle. Maybe 4, 3, 6 and 5, they are same. 1 and 2, they are same. But when you look at it carefully again, If you look at phase 4, you see, for example, like this, we have 3 dimensions. That is, if we consider this as our length, then we will have to consider this as our height, because it is height, and then in that case this becomes our breadth, or maybe this becomes our breadth. So this is like a 3-dimensional figure of a cuboid. Okay, 3-dimensional figure of a cuboid. So you can see here very closely, so if you look at it like this, then what happens? If you look at it like this, then we have this, we have this height, we have this length, and then of course we have this breadth. Now let's find out the area of each of these faces one by one. Okay, let's do it quickly. So for phase 1, we need 1 what will be the area 2-dimensionally? So see, if I'm placing the box like this, okay, you can even hold your textbook and then check. When I place this box, if I just take this as a 1, phase 1. So phase 1, because it's upward, I say that's going to be by length into breadth. So it's length into breadth. What about phase 2? Phase 2 also is going to be same. Phase 2 is also going to be length into breadth. Similarly, but what about 3? Let's just check it out. 3. What will be the phase 3? Phase 3 is going to be height into what? Height into breadth, isn't it? Height into breadth. What about phase 4? So phase 4, if I am placing it like this, so phase 4 length into height. Phase 4 length into height. So that means phase 6 will just opposite to 4 will also be length into height, and then that means phase 5 will be breadth into height. So so phase for that you can do one thing, you can just mark me the way I've marked here. This is height, this is length. So this is also going to be length, right? Of course you can maybe use a shoe box or a textbook that will give you more example. This one is so that's how we find out. So now it has 6 faces. So if I have to find out now the face area, total area of all the 6 faces, what will be the total area of all the 6 faces? If I add total, we call it total surface area, because I like choita surfaces. So we call it total surface area. So what will be the total surface area? When you add all the 6 faces, we will have LB, L into B, L into B. So we have twice length into breadth plus height into breadth, height into breadth. We have 2 height into breadth, 2 height into breadth. Plus we have 2 length into height, 2 length into height. So 2 plus 2, that's what? 6 faces. So ultimately the formula that comes out is length into breadth plus breadth into height plus height into L into H or H into L. This is called the total surface area of a cuboid. Okay, but for a cube, what happens is for a cube, length is equal to breadth is equal to height. For a cube, length, height, breadth, they are all same, like a magic cube. No, sub dimension do iki thagebo, and that dimension we just use A for a cube. Okay, for a cube, I'll just give you the difference one by one. So for a cube, for a cube, if you find out the total surface area, that's going to be 2 into A into A. Now A into A plus A into A plus A into A. So that will be how much? Twice into A square plus A square plus A square. So that's going to give me, that is going to give me how much? Twice into 3A square. So that is total surface area of cube. Total surface area of cube will be 2 into 3, 6A square. 6A square. This was for cuboid. So these are the formulas for total surface area of a cube, total surface area of a cuboid. Cube and cuboid almost are same. Cube, like all sides are same. No? Height, length, breadth, all sides are same. Okay. So this is what we are going to be doing in the first exercise. It's about total surface area. But question will never be direct. There will be many twists and turns in the questions. Question the one bujibo lagibo. Okay, we have to understand. For example, at the box dishe diagram bar. Now, we can do it in many ways. Okay, so suppose at the box dishe diagram bar, to cuboid diagram bar mention kurishi. So suppose total surface area. I'll not name the condition now. Total surface area 2LB plus BH plus HL. Holibi diagram bar ko ado itu box to khula, open at the top, for example, open at the top. Tamane upor laga dole nai ko dai. It means open mane to khula, it be just space ho jaise na open. Tamane itu katina philai dibo. To yati to surface nai to itu top laga ki dai se length aro इनिया राखिछु बोले इनिया राखिछु बोले तो लेंथ और ब्रेथ थाकिछु ना तो moi length और breadth बोले subtract करिब লাগিব ना कारण ताकन question दि क्वा हिसाब pra as mentioned in the question example I mean once they say it's an open box the top surface does not exist so from the total surface area I have to just remove the upper surface that's a surface area of the upper portion so that's length minus length into breadth that means you can just re-innovate you can innovate it in your own ways no one common question again that comes is generally like four walls of a room generally which if it is a cuboid no cuboid generally rooms are cuboidal in shapes of course these days we have different shapes conventional method I mean so four walls of a room so when you look at the four walls when they say suppose painting ratio so they say that you paint only the four walls of a room so that means I'm going to paint only the four walls that means I'm not going to be painting the ceiling and I'm not going to be painting the floor ceiling or floor we paint no puribo tarmane what will be the area that I have to paint itu charta face itu charta to paint puribo lagibo so that means ekta laga to hoise length into height na to itu duita laga length into height so twice of length into height plus itu laga length into height or itu laga ki ase breadth into height twice of breadth into height because breadth into height to duita surfaces na 5 eta aro opposite to 3 eta so that's going to be twice into L plus B into H so this is one formula that we use to find just the area of four walls of a room we also call that sometimes sometimes we also call that as lateral kitiaba SURFACE sometimes we also call that as lateral surface area alright what about for a cube then lateral surface area this is going to be for a cuboidal room so suppose takan ceiling do lage koisi hole to aro edu charta wall de ceiling suppose ceiling to add koribi ceiling to length into breadth hobo length into breadth so that means we can just you don't have to memorize the formulas isn't it you don't have to memorize the formulas because as I mentioned no need because to memorize the formulas it's of no need all you have to do is memorize to remember the formula we have 2 times of length into height length into breadth plus 2 times of length into height plus 2 times of breadth into height because breadth bhi 2 bar ase length bhi 2 bar ase height bhi 2 bar hobo na duita face the so that's going to be what twice into LB plus LH plus BH that's going to be simple or when you say for a cuboid so it's same twice into a square plus a square plus a square because tala choita face to let's say in 2a square plus 2a square plus 2a square na roof ceiling square same twice of a square duita opposite sides twice of a square or duita opposite side twice of a square so it's simply going to be 6 of a square so no need to remember the formulas also okay and lateral surface area so what will be the lateral surface area of a cube lateral surface area of cube suppose your room was cubical in shape cube mane sob sides to same length height breadth ek hi hoy jabo ludo man ludo sanisna na ludo so what will be the cube to charta wall ase tamni charta square ase na charta wall mane charta square 1 2 3 4 to tamni charta square so that's simply going to be 4 into a square cube la to bishi easy ase na total hoise bole 6 ta square hobo so 6 times of side square na holibi charta wall hi hoise bole to 6 times of a square to ta baro ceiling bi hali hoise na plus ekta arita square ekta add koridibo plus a square so that's as simple as that okay so this is what we have in this chapter that's about lateral surface area the total surface area of cuboid and cube so you can even actually after this you can go and check out your your tech home and then find out cartoon boxes and then just see it's like you can just imagine okay this is the length but first you have to choose you have to decide okay this is going to be my length breadth and height in your you will also get okay just try to follow what I've given you and then you will also get practically it's much better when we do up close but of course this is the only medium with which we can reach you now so you can just go through it and then check it out okay so here in this exercise in the next exercise most of the questions will be Not given to you directly. They will just say, okay, we have to paint 4 walls of a room. What will be the cost? So to find out 4 walls of a room, I have to first find out how many kiman area paint kuribole ase. So 1 liter bra 5 meter square paint kuribole aro 1 liter la paisa 20 rupees asibole total area to 200 asibole 200 into 20 400. So I have to find out. But if I say that okay, I have an open box, open box ekta banabole ase cartoon box pa, so in that case open box banabole bole khali opor laga area din logo 4 wall laga aro niche laga do itu laga area do logo laibo. So itu one question kan to na amount ro bujibo laibo kitaba to question di digina me thaibo find the total surface area. But that depends on the question again. Total surface area mane hotai sub choita surface laga no hobo. It depends on the question. You have to read and understand the question. Okay, with that, let's try to quickly solve one question, that is exercise 13.1. Exercise 13.1. See, this is the question. I believe all of you have your textbook. I'll just read the question and then see. A plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep. Careful there. Centimeter deep is to be made. A plastic box. So question number 1, length. Let's write down one by one. What is the LNGTH? What is the length of the plastic box? What is the breadth of the plastic box? And what is the height of the plastic box? Length is 1.5 meter long. Breadth is 1.25. And height of course 65 centimeters. So we have to convert that into meter. So 65 by 100 na 100 meter di convert korisu bole to it was 0 to 2 decimal opor di ahibo tamne 0.65 meter. So it has sub eki unit hoi jaise. Question do ase it is it is open at the top opor to nai. Ignoring the thickness, okay, question do find the area of sheet required for making the box. To tagamra kwado ek the box ase opor laga do nai. Itu khula rakhibo. To damne amon 5ta surface bonabole lagibo box laga do. To tadi kiman sheet kiman cardboard wale kiman paper lagibo itu box bonabole. So damne we'll do it very simple. That is area of sheet required. Itu na area of 4 walls of a room. Itu laga concept to chalai shole log easy hoy. Okay, area of 4 walls of a room laga concept to chalai easier hoy. Because chutu add korai bhal na tamor presenter subtract korole jhamela to we will use that concept. Tamane itu laga number 1 to open na number 1 to open to itu to chaise nai. To itu charta face laga ki da isle formula area of 4 walls of a room to twice of L plus B into H. Na twice of L plus B into H. तो चारटा wall लगा दे area तो हो जैसे इतियारो floor लगा दो बिसारे बोला है ना तो floor लगा तो होता है length into breadth है ना floor नीचे नहीं आएगी शुरू तो length height तो नहीं है length into breadth plus length into breadth. Okay, so let's quickly do this. That is twice of L to कितना इसे L to 1.5 plus breadth to 1.25 into height हो जैसे 0.65 plus again length into breadth 1.5 into 1.25. Of course, we unit to lekhana next time we unit to. So let's quickly do that. That is 2 into it will be meter. So 1.5 into 1.25. What will be the addition? Addition korisu bole. Of course, kono model nijani thakibo pare. So we need add koribo quickly time ono korisu bole. That is 1.5 1.25 to add korisu. Decimal to be careful thakibo lage 572. So 2 into 2.75 into 0.65. It will alag group. Or it will multiply with 1.5, 1.25. So 5 5s are 25, 2 left, 5 1s are 5, 6, 7. It na multiply with hotai Pishula number to ra compula. I mean Pishula digits thaga number to ra compula to multiply kore bhal. I mean, comptiola to ra visual number to multiply digits visual number thaka to multiply kuri easier. So 5 5s are 25, 2 left, 5 is 10, 11, 12, 1 left, 5 1 5, 6. Decimal to nahali bide last di hali 1 2 5. So that's going to be 5 7 8 2. To kiman decimal thaise total 1 2 3. So 1 2 3. So that's going to be 1.875. Area is meter square. It is actually meter square. Okay, meter square, meter square. So now, so in that case, it multiply I think we are going to get approximately 3.575 meter square plus 1.875 meter square. So if you add this, I'll just add this here, 3.575 into 1.875. So that's 10, 1 left, 15, 1 left, 8, 9, 14, 1 left, 3, 4, 5. So 5.45 meter square. So this is the total area of the sheet required to make the open box. There is another question there, second part, which states, find the cost of the sheet if a sheet measuring 1 meter square is rupees 20. Number 2, cost of 1 meter square rupees 20. Meter square. So what will be its cost? So cost of 5.45 meter square into rupees 20 into 5.45. So it will multiply it will be 5.45 20 0 0 0. I'll just multiply. Okay, we shortcut it is now 5.45 20 ratio 2 multiply 2 5s are 10, 1 2 4s are 8 plus 1 9, 2 5s are 10. So 20 la 1 2 multiply to ekta 0 hali dibo na to duita decimal ahibo 1 2. So that's going to be rupees 109. Okay, so this is how you will be doing this chapter. So it's not a very difficult chapter. All of practice lagibo. Our question to bujibo lagibo na takan box dina lagibo kitiaba upor to khula kitiaba niche to khula kitiaba charta wall le hale chinta nokoribe amon sob biki lodi milagina puribole ase milagina puribole ase. So alright then, so if you have liked this video, please do like the video and then of course share with maximum of your friends. Okay then, alright then, stay safe, take care.